Hello, my name is Kim, and today we're going to be going over video assignment number 11, integration by parts. Before I get started on problem number 1, I want to recall the integration by parts formula, which is the integral of u dv equal to uv minus the integral of v du. Essentially what we are doing here is making a whole new equation where our integral will be easier to solve. Now when we start to choose our u, what we want to do is go in the order of logs, inverse, algebraic, trig, or exponential. The way I remember this whole abbreviation here is let's integrate all the equations. So it's logs, inverse, algebraic, trig, and exponential. So the equation that I'm going to be using as an example today is the integral of 3x ln of 5x. The first thing that I did was I applied the constant multiple rule and I took out that 3. So I just set the 3 outside of the integral, and then we were left with the integral of x ln of 5x dx. But don't forget about that 3 out there because that's still like a part of the equation that we're going to use. So as you can recall from earlier, I said that you would have to identify your u and your dv, which is the first part of that integration by parts formula, because we're going to turn it into a different equation. So, like I said, you have to choose your u by trying to identify any logs first, any inverses, algebraic, trigs, or exponential. In our case, the first thing that pops up, coincidentally, is the logs. So we have a natural log here of 5x. So we're going to make that our u, and then what we have left over is the x, so that's going to become our dv. So now we have u is equal to the ln of 5x. Our du, which is the derivative of the ln of 5x, we just get 1 over x. And then our dv is going to be equal to x dx. And in order to get v, you would have to just take the antiderivative, which would be x squared over 2. So at this point, we've pretty much gotten through the tougher part of this equation. We have identified u, du, dv, and v, which is all we need to solve our integration by parts formula. Our original equation of 3 integral x ln of 5x dx, we can now rewrite that in our integration by parts formula. So remember that we have that 3 out on the outside, and then we have u dv, so it's ln of 5x times x squared over 2, minus the integral of x squared over 2 times 1 over x, which is that v du part. So now I just simplify the first part up here, and that comes out to x squared ln of 5x all over 2, and then we subtract that integral again. So when we multiplied the x squared over 2 times 1 over x, we ended up getting x squared over 2x, and then when you simplify that down, it comes out to x over 2. So it's still minus that integral of x over 2. We didn't do anything yet, we just simplified. So now when we do take the integral of x over 2, which is a super easy integral to take, we know we just increase the power by 1 and then also multiply that power onto the bottom. So then we ended up getting x squared over 4. And it's still going to be a part of that equation. So now we have 3 times x squared ln of 5x over 2 minus x squared over 4. And remember that 3 is going onto the whole part of we're distributing that onto the whole part of the equation, not just the first part or the second part. So then what we ended up getting is 3x squared ln of 5x all over 2, and then minus 3x squared over 4. And then we add that plus c on, because we're taking an indefinite integral, and then that's what we're left with. Okay, so moving on to the second part of the video assignment 11. For number 2, we have true or false. The integral of f of x g of x is equal to f of x integral g of x plus g of x integral f of x. And we're integrating in terms of x for all of them. Okay, so now all that I did was I rewrote that equation that you just seen in the last picture. So it was the f of x, the integral of f of x g of x d of x equal to f of x integral g of x d of x plus g of x integral f of x d of x. Once again, that was just the equation that was in the picture before. Okay, so now I'm going to prove if this is either true or false. And I'm going to do that by applying that integration by parts formula onto the first part of this f of x, g of x, d of x. So this whole equation is just the equation that we just seen in the picture before. So what I want to do is, first let's recall our integration by parts formula. So that formula is the integral of u dv equal to u v minus the integral of v du. Okay, so we're going to take the first part like I said up here. So we have f of x, g of x, and then dx. Okay, so now we're going to try to get that into this integration by parts formula. Since this is a general formula, I'm not going to be looking for any like logs or exponential, algebraic, or anything. It's just pretty much just a generic way of trying to get into this. So I'm going to make u equal to f of x. So I'm going to make this my u, and I'm going to make this my dv. So u is going to be equal to f of x. du is going to be equal to f prime of x. Our dv is going to be equal to g of x, and then our v is going to be equal to the integral of g of x. So now we have our u, dv, du, and v. So now we can start making this equation over here. Okay, so since we have identified our u, dv, du, and v, we can now start plugging it into our integration by parts formula. So for the u dv, we're just going to plug in the f of x, g of x, and then it's going to be equal to uv, which is f of x, and then the integral of g of x, because v is an integral all by itself, so it's the integral of g of x. And I pretty much got v from taking dv. So when you take the dv of something, it's just taking the antiderivative of whatever it was. So I'm just taking the antiderivative of g of x. Since there's no real g of x, you just put the antiderivative of that g of x, or the integral of that g of x. So now we're going to minus that by the integral, because in the integration by parts formula, there's an integral already. And then since v is an integral itself, we put that integral of g of x. And then du is going to be f prime of x. Now, here it looks a little messy, so I'm going to explain like what's going on here. You have that original integral, and then you're taking the integral of g of x, and then you're multiplying it by the f prime of x. Basically, what you're doing here is it's kind of like the constant multiple rule, where you have that, you have that integral of g of x times the f prime of x. So you know how in a constant multiple rule you move out something and you set it on the outside, and then it's times by whatever it is. That's kind of what this f prime of x is doing here. So instead of having it as something that's outside of the integral of g of x, I'm going to tag that along inside with that g of x. So it's going to be the integral of g of x times f prime of x. So it's kind of like this. So it's kind of like the integral of this. So it's the integral of a smaller integral of the g of x times f prime of x. Now I want to zoom in on this, so I want to see if I can get this down to something smaller. So I come over here, and this is what I'm working with here. So once again, the integral of a smaller integral of g of x times f prime of x. I'm doing that because I want to apply the constant multiple rule on this inside integral here. So when I apply the constant multiple rule on this inside integral, I'm basically going to push that g of x outside of the integral, of the smaller integral. So I'm pushing that g of x outside of it. So here we have g of x and then the integral of f prime of x. The reason being I want to do that is because I want to get rid of this prime that we have here, so this derivative. When we have an antiderivative going on top of of a derivative, it's going to cancel each other out. So then you're just left with the expression. So by doing this, we have this g of x on the outside, just out. and then we're going to have this antiderivative and this prime here cancel out. So then what you get left with is that smaller integral goes away, and then you just have one big integral of g of x f of x. So now what I'm going to do is I'm going to use that constant multiple rule again, and I'm going to basically make it g of x and then integral of f of x. Remember that prime had went away when it went away with the antiderivative, yeah. So we're just left with the g of x, f of x. So now we're going to pull back down that uv minus this g of x, f of x. So we simplified this v du part down. So now we're just going to have this f of x, g of x minus this g of x integral f of x. So now we get the integral of f of x, g of x is going to be equal to f of x integral g of x minus g of x integral f of x. And when we compare that to the question that we had, so here's the question that we had the f of x integral of f of x g of x dx equal to f of x integral g of x dx plus g of x integral f of x dx. We see that it is false because when we did our equation, just to line them up, it looks quite similar, but the thing that we got is we got a minus here. So we have a minus here, and then the question asks us, is it the same as, plusing? It's not the same, so that would make the question false. And here's the comparison. So here's what we got out when we did the integration by parts and did all the handwork for it, and then this was the question.